Good morning and welcome. My name is George Percival, Chief Engineer on the staff of OGC, and it's my pleasure to welcome you here today to the OWS-10 demonstration. And we've got a lot of presentations about demos and live demos, and lots of good results from the ongoing OWS-10 testbed. Today you'll get a little bit in the beginning from me of a bit of a retrospective and history in keeping with our 20th anniversary of OGC celebration this week. So I'll particularly talk about history of OGC interoperability program and what its objectives are. And then Lou Leinenweber will lead the discussion, MC the overall OWS-10 demonstrations. So with that in mind, let me give you a little discussion about the interoperability program. So Edison, right? Everything traces back to Edison, right? So I failed in 1,000 ways, 10,000 ways, right? But really, I'm learning is what one of the most prolific inventors of all time would have said. This is very similar to some of the bases of what we have within the interoperability program. It's innovation through prototyping. Great book called Serious Play that gets into some of the statistics, and as a rule, the more prototypes and prototyping cycles per unit of time, the more technically polished the final product. So here we actually have several products. We've got the standards, we've got the software, and we've got the demonstrations. So our intent here for innovation is to really focus on that prototyping, innovation through prototyping. The interoperability program is one part of OGC's multi-program approach. So we'll speak here mostly about the interoperability program. The standards program, sorry, I should have updated the slide. The standards program is led by Carl Reed. As you know, it's all the DWIGs and SWIGs and the TC and the PC that form the basis of our consensus process for adoption of standards. Compliance testing and certification, led by Luis Bermudez, who you'll hear from a little bit later this morning. And then communication and outreach, Denise McKenzie, who is leading that program and organizing quite a bit of the events this week about our 20th anniversary. So as a retrospective then, let's go back to the first event of the OGC interoperability program. So some of you in the room were part of this activity. These slides, even the format of the slides, may bring back some memories. It's been a little bit of a change. 1999, we started with web mapping testbed, and here were the sponsors. Many of them of you are in the room today as continuing sponsors of the OGC testbed. We also have a list of participants. Many of these organizations are still in the room, many new. I'd also call out a shout out to the architect of the web mapping testbed, Alan Doyle, who's here in the room today, and splendid to see Alan here. So yeah, we built WMS out of that. WMS came out of that, one of our most successful standards. But another thing was the process that came out of that was this iterative innovations based on prototyping philosophy of running code wins kind of approach. And so that was really a breakthrough back in 1999. We continued on through a period of initial development of that, WMT1, 2, and a variety of other test beds and pilots. And in 2001, we began what was named the OGC, now OGC, Web Services Activity Testbed, string of testbeds, of which we now have 10. Actually, we didn't put 9. So, we've done this 10 times. You're going to hear the results of that. A lot of different threads in each of those, and in fact, one of the things I'll show you is how over multiple threads, various concepts have advanced to become mature. So again, multiple prototypes leading to pilots that end up becoming mature operational standards through this activity. The framework that we have for that increasing technology readiness is the test beds are really innovations, experiments. We expect them all to succeed, but sometimes it's an experiment, and so success is a failure. Go back to Edison, right? I've failed 10,000 times. Interoperability experiments leading to pilots, which are an operational environment activity. You choose an operational environment and put the innovations, the standards in that operational environment. The thing that really comes out of there are best practices, more so than new standards. Although we've had new standards come out of pilots too, so nothing like a good rule to be broken. So Plugfest. We'll actually highlight one of the Plugfests we just had as an example of that, and then moving to OGC Network, we want to get these as operational activities. All of this interacts with the OGC standards program because that's our backbone. As we talk about innovation and prototyping, we do a lot of new and development and the like, but the key thing is to keep developing that backbone, that set of standards, the architecture that persists over time and represents the accumulation of our best understanding and our best offering to the marketplace. So in fact, let me give you a sense of that. We often talk about agile prototyping. In fact, I've seen some people claim that's all you need to do is agile prototyping. This was a study done a few years ago now, comparing the same development of the same system, one with an agile prototyping approach, another one with a top-down specification, specifying requirements and moving through and the like. And the results essentially were mixed. There were some very good attributes of agile prototyping, efficiency of the code, it's less code, that kind of stuff, better meets the user's need. What a surprise, because you're highly interacting with the users. Prototyping versus specifying does better on the ability to have an evolvable design, because you've got this emergence of a coherent architecture that allows a common shared understanding of the architecture. And so you get away from, if you will, spaghetti code of prototypes. That's a derogatory term. But what you really get to in a specifying mode is that architecture that carries forward, which in our case is the standards, the best practices, all the things that are in the standards program. So a little bit of development philosophy and the like. So one thing I did as part of this retrospective was go look at the list that's on our webpage of all the interoperability programs that are out there, and we thought it was like 40 or 50. Well, when you count them up, it's actually 85. So we have done 85 initiatives as a collective organization. That was a surprise to me that we've actually had that number, quite frankly, over 10 years. And this is the breakout amongst those Plugfest pilots, interop, testbeds, concept development, and support services, which are study activities and the like. So, a lot of activity conducted by members over these 20 years, 15 years of IP. So what does that result in? What's the result of it? Let me give you two examples of how that maturity of different domains and standards comes out of the interoperability program and goes into operational activity. So SWE, OGC Sensor Web Enablement, began in OWS-10. It was actually EPA that was the initial sponsor of SWE, and really got us going in sensor web enablement. The sensor web enablement domain working group came up with a lot of good structures, which were then tested out within the OWS 1, 2, 3, 4, and resulted in version 1 of the SWE standards, approved in 2007. So we had that slate of standards. So that prototyping of multiple iterations within test beds, along with a lot of other activities, resulted in the definition of the version 1 baseline of the SWE standards. What's happened since then is that there's been implementation of those in pilots, in operational environments in which we refine and mature the version 1 standards. So on the left, the DoD IC intelligence community sensor web can be directly traced to results from a pilot called Empire Challenge. There was actually 3 years where we participated in Empire Challenge, and the result of that influenced a lot of what's in the DoD world. In the middle, we had an interoperability experiment called the Ocean Science IE. We actually had 2 of those, and those ended up heavily influencing what is now the deployed operational NOAA IU's buoy system using SOS. And on the right side, the OWS-5 testbed and some pilots that were conducted within NASA and CEOS and the like led to the EO1 sensor web, and now an emergency response, emergency disaster response architecture best practice coming out of CEOS that we regularly work with. So there you see, the application of that innovation resulting in operational systems. Similarly for aviation. So there's a bunch of bills in here. So in any case, aviation kind of came along in OWS-6 with what was called Axum. It was kind of the first thing that was the basis of a lot of activity. One of the guys that was at Eurocontrol said, maybe we'll use GML for this thing we call the Aircraft Information Exchange Model. I think I got that close to right. Axum, A-I-X-M. And then we put that into the testbed process. And out of that Axum and a set of services and the like, we actually did several testbed iterations of aviation. We did a special airspace SAA pilot related to reserving airspace for a special event like a president flying through an area or something like that. That pilot was in the operational environment of FAA and resulted in what is now operational, near operational, they're testing, operational activities within the aviation domain. So let me give you a sense of what aviation looks like in OWS-9, the maturity of what we've got there. So that should go here. Unmute.
In order to create new solutions, as well as enhance existing ones, OWS-9 aviation participants worked on improving application client components and services for information discovery, management, processing, portrayal, and communication management. The development process involved a range of investigations and analyses, for example, with metadata management, with system stability, and with modeling support. Creating a system that provides aeronautical information to support international flight operations involves end-to-end communication between services on the ground and client applications in the air. The information is portrayed as graphically as possible so that users can more easily understand it. The results include both publicly available engineering reports as well as actual prototypical implementations that are based on standards-based commercial off-the-shelf software.
So it's just a quick video to show you aviation. So that what came out of the OWS-9 kickoff, give you a sense of the magnitude of the folks involved, at least at the kickoff meeting, so it's even beyond that number of people involved in the activity. The last example I'll show you of an activities that are going on right now is a very recent one, and that is a plug fest. This was conducted, it's called the UK Interoperability Assessment. It was conducted at the Ordnance Survey over the last few months, very recent results. And the key there is they have operational WFS. They have several 100 million features in GML at Ordnance Survey. And so serving that up in WFSs to clients that have never seen those WFSs before is really critical. And so that's exactly what was tested. Both WFS, WMS, WMTS, KML with operational code in the Ordnance Survey setting to show and mature the standards, even beyond adoption, even beyond compliance tests. There's still the need to conduct things like Plugfest to work out further iterations of interoperability. Let me finish off then with a little bit on the process of the interoperability program and the objectives and the like, and that'll lead into our OWS-10 demo. So interoperability is easier said than done, of course. We all know that in the room. What we need is collaboration. We need agile development. We need to share the cost of developing that to reduce the risks. Public-private partnerships to be able to get industry in the right spot to be able to support our agency's needs. The interoperability program is proven 85 times, 85 initiatives. Sorry, I'm still surprised about that. I did that the other day. Effective process, repeatable, competitive, cost-effective. So the ingredients for success and wonderful slide of the things that pull the interoperability program together. So deliverables, what you'll see here is mostly demonstrations backed up by prototype implementations. The other key thing though is the technical documentation that goes forward to the standards program. So return on investment, there's participants and sponsors, and and in particular, we've demonstrated over and over again the return on investment of about 3 to 5. So every dollar or euro of investment nets $3.5 or euros of actual effort and labor, because people are looking to participate, to reduce risk, to understand their customer. Let me finish with a slide. Let me move on.
I think one of the big considerations for anyone who's thinking about joining is that when you participate in this process, you are not only contributing, but other people are contributing as well, and not only their technical expertise, but financially to the process as well. So you leverage your money in a very effective way.
It was impressive to see that openness and the way the team worked together to come up with solutions to issues and remain focused on the end product.
DSTL recognised quite early on that the OWS test bed was a great way of getting new concepts embedded into new technology quite quickly, so that we can actually answer our soldiers' requirements in a quick and efficient way.
Global harmonization has been a big buzzword around the FAA, especially with our development of next gen, but it's more than just a buzzword, it's a way for us to focus our efforts of development.
So for DSTL, the real benefit of the OWS is that the OGC makes everything really easy for us, and it takes into account things like IP problems, brings the communities together, and enables us to concentrate then on the real technical problem, and allows us to focus on that and get the answer quicker than if we were about to do it ourselves.
Lockheed Martin's been very active with OGC for many, many years, and one of the reasons that we've gotten a lot out of it is because of the Open Web Services testbed activities. So they're so practical. As an integrator, what you find oftentimes is that you have an enterprise solution, a need is driven by a mission. And if you don't have an environment where you can try things out that are driven by the mission, by the users, by the scenario needs, you never really get to the tough parts, the things that cause trouble for the users or cause trouble for sharing information. And in the test bed, you oftentimes learn things that otherwise you wouldn't discover until well into an acquisition, and then it's too late.
One of the advantages of getting involved within the OGC process is it allows you to rapidly develop new products, new services, new ideas very quickly with minimal cost.
It's very useful to participate in the OWS project. Benefits that we get out of that is that we can experiment with new standards. We can work on interoperability with other participants. And that allows us to say to the stakeholders, to the sponsors, to prove that our software that we provide is interoperable with a lot of other vendors out there. And I think that is a very strong statement that you can make due to the OWS project.
The OGC model, particularly the testbed, allows you to really try out what works together based on the standards platform. And that really allows you to bring in lots of innovation. In OWS, we saw the agility of vision come together with the agility of implementation to get to powerful results that are going to make a difference. It is the worker bees in an international consortium that have a shared conviction for how you need to put the building blocks of data interoperability together in order to create market-changing conditions that allow us to solve real-world problems.
All right, so that's what I have, but I want to thank the other person whose name is on the front slide, who's not here today, is Nadine Alamay. She's with her son, who's having surgery this morning. It's not anything major or anything, but you know, anytime a kid has surgery, right, it's major. Right? So she'll be here certainly tomorrow, maybe even later today. You may have heard that she's also going to leave us from the OGC staff, and yeah, that hurts. It's the pursuit's all good, but joy in the workplace, you got to pursue that. With that, she was instrumental in pulling this together. But we have a very strong team now that's going to give you a lot of discussion about OWS-10 results. And in particular, introduce Lou, who is the initiative director for OWS-10, and probably get slides right. I guess I got 2 minutes or something if there's any questions or not. But why don't you go ahead and get this going for the next presentation. Any discussion, questions? Thanks to all of the sponsors and participants who are here today and for your support. We are recording it on there. We're also taping it. I see myself on video. Video recording? Yes. The answer is yes.
Good morning. Hear me okay? Thanks, George, for giving us that overview, history of the OGC's interoperability program and the things we've done for all those years. So now we're going to where we are today, OWS-10, testbed 10. We're going to present you three things. I'm going to do an introduction first, which just shows you on the agenda. A little bit of overview of the overall picture of the testbed. And then we have three different presentations for the various threads, the aviation thread, the open mobility thread, and the cross-community interoperability thread. So we'll do those, and then following that, we have another demonstration, set of slides, and also some videos to show some of the things that were accomplished in this testbed in live action, if you will, interspersed with the slides to give you some details about what we actually accomplished. And to say also that in the room, around the side and in the back, we have some of our participants who are here today to showcase some of the other details of things that they accomplished during this testbed. Perhaps some technology that they use that dives into a little more detail than maybe we're going to present in the slides today and the videos, and also perhaps even some other videos and things that they've developed during this testbed. So please join them and visit and network and talk to them about what they've accomplished and among yourselves as well. So thanks for being here. So, there's George, this is me. I think George already talked about this, but the interoperability program is all about collaboration, innovation, shared costs, and repeatable process. And he's articulated that earlier in one of his slides. So just reiterating, this is what we're about here. I think it really works well. As an iterative development process, the interoperability program works in concert with the other programs within OGC, within the standards program, within the communications and outreach and interoperability program, as well as the complementary work of the compliance program, which takes the standards that we have and develops tests so that you can verify that you actually have a system that's working according to the standard. So requirements for the interoperability program comes from many different directions and can originate from many directions. Sometimes it comes directly into the interoperability program. Sometimes it comes in through standards working groups and domain working groups that originate new ideas through industry that has found there's a need or for an existing standard. There may be changes that are necessary. So they come in through that way as well. Excuse me, they may come in through communication and outreach program. We're out trying to articulate what the capabilities of the OGC standards are at various venues, symposia, other conferences, other meetings with other non-governmental organizations, through many different avenues. And through that process as well, you may collect information, and some of those organizations may articulate additional needs and changes to standards that are in place, or new ones that need to be put in place. So with all the cycle of where those requirements come from, interoperability program has an opportunity to take those requirements, pull them together in something like we have here, OWS-10, with a set of defined requirements, work on specific implementations that can prove the usefulness, and also, as George said, sometimes can fail, but the failures themselves result in a good deal of understanding sometimes the true measure of getting from a standard that's sort of works to one that really is adopted, is finding those failure points and fixing them over time. So it's always good to, I won't say it's always good to see the failures, but you know when you have the failures, you've got the additional points that you need to work on to get it to work completely to most everyone's satisfaction. And then out of all that, of course, we have the prototype implementations that come out of OWS-10. And those, in many cases, may end up with operationalized software.
Go-to-meeting enabled.
So hopefully we have some folks out there that are listening.
About 8 people online.
8 people online, excellent. Okay, so that's kind of the process of collecting requirements, getting them defined in a statement of works for participants, and then working through those, developing implementations, and also developing the documentation of the engineering reports that feeds into the standards program for consideration by the membership to be released for discussion, for best practices, and as candidate standards for the vote by the members for release. So the test bed at a glance for OWS-10 had 11 sponsors, 29 participants, deliverables I mentioned, 19 reports, that includes engineering reports, discussion papers, potential change requests, etc. 40 components, which is services and clients that are involved, for a total value of total value of $2.8 million. That includes the actual funded amount, which was $1.2 million, and the return on investment of the in-kind, which is added to that, gives a total value of 2.9 for a return on investment of 2.3. So we much appreciate the funded efforts from our sponsors, and I think the return on investment provides that extra measure of success that you might not get in another kind of an activity outside of the interoperability program. Our sponsors, their logos here. Many thanks to all of them for the much help that was provided by their funding, their guidance, the requirements that they brought to the table for conducting this test bed. There they are listed by name, in case you didn't recognize them on the screen as a logo. Much appreciated, all of them. 29 participants from all over the world. Many have been here before, but also many, in fact, who were new participants in a test bed. So we had 12 of them altogether, which were new to the test bed and participated with us very much. Hope they enjoyed their efforts collaboration with the other partners and participants. And hopefully, I'm convinced that the outputs that they've provided have been pretty amazing, considering if your first time in, it can be a pretty daunting experience initially. But they seem to, with the collaboration environment, I think we fostered in interoperability program. It makes it comfortable getting organized and getting involved. As I said, from around the world, these are the 29 participants shown by their names, and included a legend here to show you where they come from. So many US, many Europe, and we also have Canada and Australia and Taiwan who are involved as participants. So the threads I mentioned, we have 3 threads: aviation, open mobility, and cross-community interoperability. So aviation, as mentioned before, it's all about involving AIXM, the Aviation Information Exchange markup language, AIXM, FIXM, Flight Information Exchange model information. We looked at generating and validating FIXM in this test bed, having some tools to be able to work with that. Exchanging of terrain data was a new aspect of this test bed. And human factor portrayal of digital NOTAMs was also good, and many more things. Open mobility. Cloud was an important part of this thread in open mobility. Looking at performance and how OGC services can be deployed in the cloud. Mobile data, packaging, geopackage. Looking at that in greater detail now that we have the geopackage standard. Implementing that and looking at different ways to deploy it and use it in this test plan. Context sharing. OWS context was part of this test bed, testing how it can be used in real practical implementations. JSON encoding is a consideration. Annotations, and also, although only on a reporting analysis and report basis, but taking a look at OWS context in how it can be used in collaboration with the National Information Exchange model, NIE, which is a big deal in the U.S. So there's an engineering report which Enricia has taken as a task to investigate that, the use of OWS context and NIE together. Cross-community interoperability, looking at domain ontologies and semantic mediation. VGI, volunteer geographic information. Linked data, global gazetteer, conflation, provenance, lots of good stuff in here. And looking at overall service profiles and how those play together. The schedule. The test bed started back in January, a year ago, 2013, collecting requirements, sitting down at the TC meeting with folks just like we're going to be doing later for OWS-11. Initially gathering lots of inputs, ideas, etc., putting them together into an RFQ, which was released in July. Then collecting, receiving their proposals against various tasks against the RFQ. Coming together as a kickoff. We had a little different this time. We had 2 different kickoffs. We had one for aviation, which is conducted in Frascati, and then the other threads, the CCI and Open Mobility, conducted their kickoff at George Mason in October. So from the kickoff to now, we've been working really hard to get to completion of the tasks that were required, including the reports and the demonstrations and the implementation. So I think we're coming along well there. Today we'll present you what we have at this point in time. Since our project really doesn't end until the end of April, there's still some work to be done. Still some implementations that probably some of the participants want to keep working to work out some of the kinks and some of the bugs that may still be there for a full, more robust demonstration. So we'll be working that until the end of April, and then the final deliverables, of course, at the end of the project. Many deliverable reports, as I mentioned before. Aviation has 6, open mobility has 6, and CCI has 7. So it's rather evenly balanced in that respect. And lots of good topics. You want to be checking those out. Some have been presented this week with motions to request that they be recommended they be released as public engineering reports. Others will be coming along later since the reports aren't done yet, and perhaps they haven't reached a final consensus among the participants that everything is there that needs to be, or they need to work out additional details and get some more content. And so we'll be working to get those finalized as we go along here towards the end. Expect what we'll be doing is having a collection of a batch recommendations coming from working groups for the respective engineering reports that will be made available over the email. We'll make those recommendations to the TC, and then through the TC we can ask for Carl will run the motion to approve the release of those reports as public engineering reports. But that'll come along later. We'll do that in some batches as they get finished up. So as a patent call, I think the obligatory patent call we have to make, since things that we're doing here may involve, make sure we're careful about not including other IP that's not appropriate to be in the test bed. So this is the patent call to make sure that as we read that the IP initiative is being conducted under the policy regarding intellectual property rights adopted by the OGC. We also view and download a copy of that policy from the website. If any of you are aware of any claims under any patent applications or issued patents which would likely impact the implementation of the specification or other work product which is subject to this initiative, please inform me or any other OGC staff. You need not be the inventor of such a patent or a patent application in order to inform us of its existence, nor will you be responsible for expressing a belief that which turns out to be inaccurate. So from there we go, the next phase here of our presentation this morning is starting with thread presentations. And the first up would be on the agenda is Johannes, but I think he's not online yet. I don't know if he is or not. Check if he is.
I am.
Oh, very good. And you have slides that you can show?
Sure. I mean, with the slides you have on your machine.
I don't know if I have the latest one, sure, is the question. I don't think I have the latest ones. So can I just hand you presenter?
Sure.
Getting it, I hope. Is it, are you seeing? Yeah? Johannes? Oh, there we go.
Yeah, I'm still here.
There we go.
Ah, perfect. Okay. Okay, can you see my screen?
Yes, we can. glitch in the middle.
Okay, 1 second.
Much better.
Okay, good, thank you. Right, so hello to everyone in the meeting itself. My name is Johannes Echthoff. I'm the thread architect for OWS-10 Aviation. In this presentation, I will give you an overview of the aviation thread. I'll briefly discuss the deliverables and then actually present the different topics we have been working on. Please note that the work is ongoing, as Lou just said. The final results are expected at the end of April. At the end of the presentation, we will watch a short client video, which hopefully, Lou, you've got on your machine. We'll see that. So before I start, I'd also like to note that there's just too much good information in this slide set to be presented in 30 minutes. It's the time limit given to me. So therefore, some slides in this presentation are hidden. If you're interested in details of our work, you're welcome to download this presentation later on, or of course, get directly in touch with our participants. Good, so let's take a brief look at our deliverables. On the left-hand side, on this slide, you see the list of engineering reports and other documents that will be delivered. They become, as I said, available at the end of the testbed, or rather, I should say, after the testbed sometime. The next slide shows the different components that were provided and implemented in OWS-10. At the bottom left, we have a web coverage service for weather information, which adapts the web gridded document service provided by the US National Weather Service. We also see a web feature service that provides access to aeronautical and flight information. The latter being imported from fixed data sources provided by Harris Corporation and Eurocontrol. Updates, for example, digital notams and fixing events published by the web feature service can be processed by the event service, which is shown in the middle. The AXM validation service can check that a given AXM dataset adheres to AXM business rules, which goes beyond simple XML schema validation. The client component shown at the top requests, receives, processes, and displays the different types of information. Finally, on the right-hand side, we see two additional components. The conformance test scripts support checking of geometry requirements in GML datasets, while AXM bindings support the development of Java and .NET applications that process aeronautical information. Let us now take a closer look at the different work topics. First of all, I'd like to briefly mention that this time we were dealing with 4 different types of geospatial data: aeronautical, weather, flight, and terrain information. Some of you may know this picture, which is from the AXM website. It has been around for quite some time. However, I'd like to just point out that OWS-10 is the first OGC testbed where we have a demonstration that incorporates the use of all 3 information models: AXM, WXXM, and FIXM. So that's certainly a great thing, great achievement. Now, we had 6 work areas, each of which I'll present on the following slide. First work area is concerned with interoperable information exchange. The aim of this work area is to demonstrate the use of FIXM within our architecture based on OGC and ISO standards. A key aspect here is to test if FIXM implementations can follow the same best practice as AXM and WXM through adoption of these OGC and ISO standards. In order to incorporate FIXM data into our architecture, web feature services must be able to serve flight information as GML application schema compliant data. The official fixed-film schema, unfortunately, is not GML compliant. So therefore, we had to transform it, which was supported by existing software tools. We were then able to import fixing data from existing sources and serve it via web feature service. So what are the benefits of this work for the aviation community? On the one hand, our approach can dramatically reduce both cost and time for realizing FIXM implementations. On the other hand, the approach better aligns FIXM to AXM and WIXM, allowing them to interoperate and reference each other. Being built on globally implemented standards, AXM and WIXM are compatible with hundreds of existing tools and are understandable by communities across the globe. Standards-based services such as the Web Feature Service and Web Coverage Service can be used to access this data and thus replace or at least adapt custom-built silo services. With our approach, the same can be achieved for FIXM. This interoperability and openness is at the heart of the net-centric vision of system-wide information management, which is an important concept of the aviation community. The second work area is concerned with the exchange of weather information. The US National Weather Service can provide access to a large archive of weather data via a special web service, which they call the Web Gridded Document Service. This service is similar to the OGC Web Coverage Service, however, there are some differences. The goal for us, therefore, was to analyze if a mapping of the WGDS model to our OGC and ISO models can be established. If a mapping exists, Web Coverage Service Adapter component should be implemented, which realizes this mapping. Well, long story short, we were able to identify such mapping and create a WCS adapter via which weather information can be retrieved from the WGDS. Via this standards-based service, the aviation community will be able to easily tap into the wealth of weather information provided by the National Weather Service and access the data in an interoperable way. We also investigated the topic of terrain data exchange. The driver for this work is the requirement for states to provide their electronic terrain and obstacle data in digital form. One issue is that there are a number of potential formats for representing terrain data. However, they need to satisfy aviation-specific requirements. Another issue that the aviation community faces is the seamless integration of terrain data across borders. Finally, there is a growing interest in the European aviation community to providing and accessing terrain data in an inspired and compliant way. In OWS-10, we therefore analyze these issues and try to provide recommendations. The investigation for suitable terrain data formats encompassed the terrain information exchange model draft from Eurocontrol, the elevation surface model draft from Digivic, and OGC GeoPackage. Details on the suitability of each of these formats will be available when the engineering report is published. The analysis of cross-border differences in terrain data, as well as INSPIRE-compliant provision of and access to terrain data, is still ongoing. So let's get to the benefits of this work. The identification of at least one terrain data format that satisfies all requirements would greatly benefit the aviation community, giving them directions and guidance. We also hope that our recommendations for handling terrain data in a cross-border use case, as well as INSPIRE-compliant access to terrain data, will provide also useful guidance to the aviation community. As we all know, visual representations can significantly improve the process of determining relevant information from a large amount of data. Portrayal, therefore, again, was a topic in OWS-10. This time, we focused on human factor-based portrayal of digital NOTAMs. So digital NOTAMs represent aeronautical information updates, such as the closure of a runway, which therefore contain critical information. It is essential that this information is processed correctly by users, for example, pilots. The SAE G10 working group developed recommendations for the graphical display of node time information by onboard systems. So the goal for us in OWS-10 was to analyze and prototype these recommendations and assess if the OGC side layer descriptor and OGC symbology encoding standards support them. Work on this topic is still ongoing. However, the screenshot on this page show that some of the recommendations for human factor-based portrayal, as defined by SAE G10, powered with OGC standards-based software. In OWS-10, we also dealt with compliance work. GML compliance tests were developed, an AIX and validation service has been implemented and enhanced, and the WFS temporality extension is being revised. Correct spatial information is important for the aviation community. For the representation of geometries, AIXM uses GML. The aviation community has created a document that provides guidance and that defines a profile of GML for use with aviation data. Before OWS-10, no executable tests existed for geometry requirements defined by this document, but especially defined by ISO 9136, so GML, and ISO 9107. In OWS-10, an executable test suite was developed, with which at least a subset of these requirements can be tested. The test suite covers tests for a number of geometry types and constraints, which are shown on this slide. The test suite has been incorporated in the team engine and is not tied to any particular application domain. It can be used to test standard GML geometry types and elements, as well as derived geometry types, such as those defined in AIXM. The test suite developed in OWS-10 is therefore not only of use to the aviation community, but actually to the geospatial community. Validation of geometry types has been one aspect of our compliance work. Validation of aeronautical information encoded in AIXM was another aspect. So we get on to the AIXM validation service. This service, the AIXM validation service, can be used to validate a given AIXM dataset against a set of AIXM business rules. As mentioned before, this goes beyond simple XML schema validation. So in this testbed, the service has been enhanced and will be configured to support the latest set of AIXM business rules. The service represents a reusable tool that the aviation community can incorporate in aeronautical information workflows, especially to improve the quality of information. Another aspect of the compliance work was the revision of the Web Feature Service temporality extension. In previous interoperability testbeds, we found out that limitations of the Web Features Service standard exist when it is applied to dynamic features such as AIXM. Work on a Web Feature Service extension to better support querying of dynamic features therefore started in OWS-8. The resulting discussion paper, however, did not meet all the formal requirements of an OGC in this testbed. The revision work includes compliance to the OGC specification model, but also some revisions of the conceptual model of the extension, as well as XML schema, and further improvements include the creation of additional examples. This work laid the foundation for creating dynamic feature data via Web Feature Service in general. So other domains that would like to model, encode, and exchange dynamic features can use this specification as well. When it comes to the efficient exchange of dynamic feature data, the Web Feature Service temporality extension can thus be of use to the geospatial community in general. With the formal improvements to the specification, it is ready for implementation and testing. More implementations would enable the specification to move forward along the OGC standards track. The last work area is about the development of AIXM bindings for Java and .NET. So why are we concerned with XML bindings in the testbed? Isn't the creation of such bindings a common task for every software developer dealing with XML? Well, for sure, XML binding technologies have been around for a long time, and XML encodings are used in many domains. As it turns out, the complexity and verbosity of the XML schema gives developers quite a hard time creating useful bindings. Therefore, we were tasked to investigate the creation of XML bindings for both Java and .NET. We were able to create JAX-D bindings after some manual adjustments to the AXM schema have been applied. For .NET, we encountered some issues, but the analysis and tests to solve these issues are still ongoing. The participants also invested additional efforts, for example, to do a performance assessment for the resulting XML bindings and to integrate them in running code. The results of this work will be publicly available to the aviation community and hopefully makes life of AXM implementation developers easier. Let us now take a look at some of the new features that have already been implemented. So, and with that, Lou, I'd like to hand it back to you, just so that you can show the demo yourself, the video.
There are 8 other callers on the call.
Lucia, is that the right one? Johannes, or you want?
Yes, it's called Lucid Aviation Client Video. Before you start, can you share screen just for the others once remotely attending?
All right, yeah. Seeing it now?
You can see your screen, but not the video. Not yet, at least. Out there. Okay.
For OWS-10, the application is based on Lucia's OGC standards-based software components. As in previous aviation threads, the application allows you to connect with web feature services to query AXM data. Users can select a service, choose the desired AXM feature type, and also select a number of filtering properties. For instance, we can query airspace data above Europe. Or we can also query airport-heliport data. The resulting data is being visualized according to ICAO Annex 4 charting guidelines. Users can also select individual features and retrieve more information about their properties, such as time slice information and metadata. A new research topic in OWS-10 is the use of web feature services to deliver flight plan data in the fixin format. To demonstrate this, the client allows connection with the web feature service and query flight plan data according to a number of filter properties. In this example, we query a flight plan based on its global unique flight identifier, or GUFI for short. The GUFI used here refers to a flight from Orlando International Airport to JFK, New York. We can simulate the actual flight using a time slider in the application. Similar to the Axum use case, we can also select the flight plan and view its properties, such as the flight identification and the aircraft description. Another research topic in OWS-10 is the portrayal of digital NOTAMs following the SAE-G10 human factor-based portrayal guidelines. We will demonstrate this using a digital NOTAM that closes a runway at JFK Airport. The digital NOTAM itself is assumed to be published by an aviation authority. For demonstration purposes, we use web client to publish the NOTAM to an event service. As the application is subscribed to this event service, it will receive the newly issued NOTAM. The user can choose to inspect the NOTAM and to visualize the event graphically on the map. We can immediately see the closed runway, indicated by the red hatching pattern on top of it. This styling follows the SAE-G10 rendering guidelines and is represented using an OGC symbology encoding style. A final demonstration topic in this application is the visualization of ETOP data, referring to electronic terrain and obstacle data. Within OWS-10, terrain formats are being researched that comply with ICAO Annex 15 and ADQ requirements. The application demonstrates the use of Axum to represent obstacle data and Tixum to represent terrain data. This video featured the Luciad Aviation client to demonstrate a number of ongoing research topics within the aviation thread. Based on these tests, we can already conclude that the OGC services are well equipped to distribute both Axum and Fixum data.
So that video actually concludes my presentation, so that's it. Thank you for your attention.
Thanks, Your Honor. Next.
Okay, so I'll start.
Yep. Let me give it to you.
Okay, so this is the open mobility thread. The name doesn't mean a lot, really. It's kind of the grab bag of technology topics that didn't fit into a domain like aviation or semantic interoperability. So last year we called it innovations. This year we called it open mobility because I think everybody was jealous of the innovations name. And so, like I said, there's not a lot that ties it together, but we worked a little bit on mobile devices. A big focus of the thread was the geo-package format, which is optimized for mobile devices, so there's mobility there. We talked a lot about cloud, moving OGC services to the cloud and what happens there. It's kind of a new testing area for us, and data is mobile throughout cloud, so that's where we get the open mobility idea. Like I just said, we had the main topics were cloud computing and moving data to mobile devices. And throughout all these things, throughout a lot of the things I'm going to talk about, is the new OWS context document, which was developed over the last couple of years. And it's really a way to package up all your links to services and all your files in a single XML document. And we're mature, so that finally got to version 1.0 status late last year, I think. And this started 5 years ago when Atom and XML were very big. Now JSON is becoming a much more prevalent developer tool for encoding format. So one experiment we had was to translate context into JSON format instead of XML. And also experiment with the ability to take this contextual information, the spatial contextual information about where are all my services, where's all my data, and put that into other formats, other common information encoding formats like NEAM that we mentioned, the US National Information Exchange model, to be able to integrate those two things, and also maybe to slip some annotations in there. So one of the biggest things I think we've been doing with mapping for centuries, if not thousands of years, is you get a map and then you draw an arrow. This is where we got to do something here. And we don't really have a standard to do that after all these years of 20 years of OGC and 15 years of test beds. And we actually did work on that early on in the early 2000s, and that technology never quite made it to a standard, and we're still working to get there, to get the right format for that information. Talk a little bit about that. And then finally we had, which I'm not going to talk about a lot about after this because it's not really demonstratable in a visual sense, but we had some work on better integrating our services so that, hard to really explain, but so that they work better together, so that a client can move between services easier. So hook together the fact that if I search for some information, I may find that data available in a web mapping service, but that underlying information may also be available through a web feature service. So not only can I get a quick picture and images, but I can get at the actual underlying vector data when I need it. Or maybe in the case of raster information, I'm getting a quick WMS view or a WMTS, web map timing service view. But eventually, when I get to exactly where I need, I can download the geotip through a web coverage service, so I can get the net CD output of really scientific data when I get to just the area I need. And so, tying together those service, that sort of flow of service access, we call it integrated client enhancement. And so right now, if you have a WMS, if you're accessing a WMS and you have roads data, you're seeing roads data, there's no way to know if that roads data is available in a web feature service somewhere. So that's one example, one concrete example of what we're trying to expose more explicitly through the OGC service, through making changes to the OGC services, maybe in the capabilities documents. So that's really something to read in reports, not really part of the demonstration. So we have, here's the mandatory slide on what we delivered. As far as engineering reports goes, I mentioned that we have one coming out on the conversion of the context document from XML to JSON, and that's actually been done in an automated way using XSLT transformations, I believe, to go to, so that whenever if you're exporting XML, it's very easy to just go straight to JSON. We have that OWS context and name, and then OWS context with annotations reports. We have this fine enhancement of service integration. I think we finally decided to call it the service integration engineering report. And we have a lot of our cloud work is described in the performance of OGC services in the cloud. We'll talk a little bit more about that later. And then we have, I'm going to split out your report into two, I decided. So we're going to have two reports on related to GeoPackage. One on geopackaging, which is about the workflow to create a geopackage, and one on geosynchronization, which is about synchronizing geospatial information in general. And we had a lot of software developed during this thread. We had a lot of geopackage creation tools. A lot of the companies did different experiments on how they would like to create geopackages in different scenarios. And we had some clients accessing those geopackages and also firing off requests to create geopackages. And you'll see some of that in the demonstration. And some of these clients also made use of the OWS context document, which has turned out, I think, more and more to be a great format to just share situational context. Just these are the things you have to work with. And for example, one of the things, well, I'll talk about that in a minute. Turns out that it has much more usage than we initially envisioned. And then we have a OWS context client in UAB, which we'll see a little bit, some geopackaging web processing services. And then a lot of cloud. The cloud stuff we broke into infrastructure services, which are just how do I provide a cloud into which you can put software. So we had Amazon participate for the first time. GNU did some work on creating cloud services. TerraUA has a very mature cloud infrastructure being built up in Europe. And then on top of those, we deployed cloud-based OGC services. KubeWorks and Geomatis, CNES and TerraUA, and a bunch of people. I think we found it very easy to just, as it should be, to put OGC services on the cloud and scale them and fire up different virtual machines, and you'll see more of that develop. So we always have some change requests in the project. Luckily, the question marks, hopefully you end up not having to change standards. And so the question marks mean we don't think at this point that we're going to need change requests on those standards, which is a good thing. But just want to let you know that those work items are addressed. So now I'm going to move into a little bit of a systems description of what we did. So one of the main things we talked about was geopackaging. So we had in the last test bed and over the last 2 years of working groups and test beds, we developed a geopackage file format standard. And I won't talk a lot about that, that's another presentation. But basically SQLite-based standalone file format works great on mobile devices, and because SQLite is available on every platform, every computing platform you have. Geopackages can have spatial raster data and vector data, which is great. Well, one thing we want to do in this project is talk about how you bring the creation of geopackages into an OGC services architecture. How do you take information in GML, WFS, web mapping service, and get that all into a single geopackage. You can have multiple data sets in a geopackage. So we worked on the development. Actually, the first thing we said was, well, we also want to talk about synchronizing data and keeping it current. Could the creation of data in the first place be a special case of synchronization? And we started to work with that idea for the first month or so, and decided that's too complicated. Synchronization is still an issue we don't understand that well. I think the geospatial community in general does a great job with synchronization or revision control, and getting that kind of interoperability level is was too complicated. Maybe in 10 years we'll get there. But so we sort of fell back to a traditional OGC services approach to creating a geo package, which is, let's call it a processing service. It's really a process of creating information. So we created a profile of the web processing service for geopackaging. So basically, you tell the service what data you want packaged up, and then it'll give you back a geopackage. So we said, so how do we tell the service what data we want packaged up? The WPS requires an XML input to say what you want done. And we have this context document, which is already in XML format, and it already has a bunch of data sources in it, already has a great way to describe, where data is in what service and what portion of the data, constrained by bounding box you want, or any other kind of filter. So the context document turned out to be a perfect way to tell a WPS what to do. So everybody just use that. Context document input to the geopackaging WPS. Geopackaging WPS reads that, and theoretically the context document can have any kind of file format in there. We focus on WFS and WMTS. And so the services reached out to those, grabbed data, put it all in a geopackage, and returned that geopackage with the context document. But now the context document not only has those references to the original services, it also has internal references to where those data sets are in the geopackage. So now you have a great little thing. You have everything in one file, all these data sets in one file. You have references out to their remote resources, their original resources, but you also have references to the local copy. And that's a great, very useful thing to contribute to people. And since it's described in the WPS, you can fit it in the whole OGC services stack. You can catalog it, you can chain it with other WPSs, and it works very well. So geosynchronization, as I said, was a tougher problem, but we're still working on it. We still have a month left to go in the test bed, and we have a couple participants here, Cloud and Carbon Project, finishing up the experimentation on how to synchronize. In the past few years, we've done geosynchronization experiments which have very much been web feature service centric. So web feature services can talk about having updates to them, or updates are described in WFS transactional language. And that's been working great, some people have implemented it, but the problem is it doesn't help you as much when you're talking about geopackages or GML or something else, where you can't assume the software can do WFS, understand WFS transaction language as a way to describe what has changed. So we really wanted to look at this from, first of all, a general IT perspective. Does the marketplace have something to teach us outside of the geospatial industry? We want to look at it from a non-WFS centric approach. And we want to look at synchronizing geopackage to geopackage, WFS to geopackage, GeoJSON to geopackage, anything. And so Cloud came into the project with an idea of eventually consistent, very resilient synchronization architecture, which is very important in a lot of the deployment scenarios I think we have, where you have military scenarios, people are going out in the field, creating data, maybe you have people not knowing what other people are doing, creating overlapping data, maybe some devices don't make it back to headquarters because they get destroyed or something. So this idea of more of a peer-to-peer model of synchronization, more resilient, less dependent on every device getting back to headquarters and synchronizing with the master, is kind of brittle when you talk about what the world really is, more crazy. You could even think about this in more mainstream volunteer geographic information scenarios. You can't always control everybody giving you information back. So I think this approach it's much more complicated to really think about. It's a little scary not to have control over everything that's going on. But I think it's a stronger, more resilient approach in the long run. So those results will be captured in the engineering report. They didn't get to demo stage by this meeting. So hopefully maybe at the next TC we'll have some geosynchronization demo videos. I think I'm kind of going long, so I'm not going to get too deep into this, but we're talking about codifying this experiment into an OGC service which has operations like get data to initialize your information to get it first. And the big difference between the WFS get features or any other sort of give me information statement is that you'll get an ID for the data set and a revision ID. So you know what version of the data you have, and you have some identification separate from the data set name that this data set is roads, for example. So it's important to have an ID separate from the service, because when I talked about synchronizing from a geopackage to WFS, you have a different architecture. You don't have any good way to know that there is some data set. And then when you go out and make changes, or you come back and just want to see if there's a new version of what you want, you can get changes operation. And with people experimenting with using GeoJSON as the agnostic lingua, service agnostic lingua franca for just quick exchanges of information. So whether it's a WFS or some proprietary service or a geopackage, all these things, at least our vision is that any of these things can synchronize with each other in the future if they can just share what has changed through with some GeoJSON statements. So the annotation work, as I mentioned, is something we've been working on for years and years and years. It turns out to be hard to do something interoperably. I think everybody's software does this in some way. But our latest experiment is to work with the context document again, as we were asked, and put in some lightweight geometry and styling to create some annotations on top of the map. So we started with, once again, the Zima engineering report from back about maybe 12 years ago. Zima is XIMA, standing for XML for imagery and map annotation. There were some great ideas. I think John Evans is here. Yeah, he wrote that originally. Those ideas really held up. I really like those ideas conceptually, but the technology is showing its age. We really wanted to move to take advantage of some new technologies. And so, although we encoded this in OWS context, nothing is really going to read a context document that well. So we wanted to make sure that it matches up well with HTML5 and some of the most modern client environments we expect this to be deployed on. So a lot of interesting issues that are going to be talked about in the engineering report, but I think the difficulty in getting to a really solid answer about annotation relates to our difficulty in general as an organization to really have a strong styling vision. So we'll talk more about that. Everybody contact me with 11 ideas later in the day and talk about really getting the full, consistent, comprehensive look at styling done. But Joan Massot from UAB CREAC in Barcelona has done some good work on experimenting with some modern approaches to the imagery annotation. And that's actually a live demo, not a live demo, but this was a real demo built with real software where an OWS context document, XML, is translated into HTML5 dynamically using XSL3. So finally, the second half of what we did was the cloud work. I don't know if anybody really understands or if anybody has a great idea of what the cloud is going to do better for the OGC services in general. I think we did a good job from the beginning in creating services or web services architecture that just works in the cloud, but I think a lot of people's bosses are asking them to show it or prove it, and so we did that this time. CubeWorks led the effort to get some performance and scalability tests being done on the cloud. And we had Amazon Web Services participate really strongly. That was a great result. And offer up basically their whole infrastructure for free for us to use for testing. And so we have a great report, engineering report coming out on testing the scalability of WMS and WMTS services on Amazon Web Services. What did I say here? And so that was one experiment we did. Move on to this. So I took this from your draft report, Hedrick, where you showed, I can't read it, but basically you could get maybe 1,200 users accessing WMTS services simultaneously and get a 0.2-second response time. I think you've scaled it up even further since this was put together a month ago. So basically unlimited scaling of OGC services when you need it, and it's not a big problem. 52 North did some experiments on setting up a hybrid cloud and meeting the quality of services requirements of Inspire, the big European project, which was exciting. And that's about performance and scalability. We also had some people do some more sophisticated experimentation with cloud-based processing and moving services around across clouds from different vendors, and doing very interesting things with moving data and moving processing to data. And I'm going to describe this first, and then I'm going to show a video. So, a coalition of companies led by TerraDuid did this. I don't know if you can read this, but I can't read it on a small screen. So you probably can't read that either. But basically the idea was this very nice workflow of how somebody might take advantage of cloud-based processing, massively scalable processing service. You might go to a main place, the TerraDuid cloud, where you search a catalog for some services that you need. Decide what service you need. That service would be fired up automatically, right? Fired up automatically, maybe deployed from the TerraDuid cloud on another cloud where the data is. And then that WPS services would be run, and scaled as high as it needed to do to meet whatever quality of service needs you have. You might get data from even a third cloud, and that was the experiment they ran. So we had the processing services deployed on our cloud appliance, which was over in Amazon in Ireland, and then some of the data was on Interroute UK. I should do this from memory because I can't read this at all. And we had basically 3 clouds interoperating at once. And I'm going to end with a video by this group of companies. So this was I don't know, do you guys call it Kines or CNES? Kines, TerraDuid, Geomatis. Am I missing anybody? Yes. Try to click on that link. So this is another multiple cloud scenario where you have you access a CSW to search for some services. In this case, it's an ortho rectification service. You find it, shows you some raw imagery that needs to be rectified, and you choose which one you want to ortho rectify. Then you go off to another cloud in Toulouse, France, to do the ortho rectification, or to get reference 3D data to do your ortho rectification. That reference data comes back to this Terra cloud in Rome, and the imagery gets rectified. Then you can use the WMS to sort of look at how well it was done, and we're going to see that happen right now. So here's the search for raw imagery. Let's see, I like that one. And then that ortho-rectified image is displayed through WMS, and then you can download it as well. You may want to look at how good the ortho-rectification process was to assess the quality through that WPS for quality assessment. And that's visualized through another WMS. And then here's a final WPS which creates a land cover classification by training the imagery, identifying some water and forestry and farmland. Here somebody's tracing out those areas. And then you send those polygons to those areas, those training areas, along with the imagery to get a full land cover classification. And there it is. So we did a lot of, I think we did a lot of strong work in the geopackaging workflow and a lot of great experiments with cloud, showing that OGC services do a great job with cloud deployments. And so we had a very fun test bed. Thank you.
Take a bit of a break here. We have an adjustment and a changeover that we need to make on the video recording here. So about a 10-minute, is that what you did? Yeah, that's fine.